Welcome to my channel. Today I want to explain why when you look out at the horizon, why you don't see a curve. And this is true even if you are flying in a plane at 30,000 feet. You still don't see a curve. Today I want to explain why that's true. First of all, what do these things have in common with you? The DNA inside the human cell, a virus, the smallest visible object to the naked eye, a human hair, the smallest detectable particle in a clean room, a raindrop, and a basketball. So what do all of these things have to do with the flat earth? Let me explain. Let's say you're shrunk down to where you would have the same scale or same relationship to a basketball as you have to the earth. So we'll start off, let's give you the height of Darth Vader. And when I read the Star Wars book back in the 1970s, they described him as being 2 meters tall. Well, 2 meters was about 6'7" in the English units, but 2 meters relative to the radius of the earth will be relative to the radius of a basketball, which is about 4.75 inches. If you divide the radius of the earth by the radius of the basketball, we've talked about the radius of the earth before, so we'll just go ahead and go with that. Save you the math this time. That ratio will come out to 5.08 times 10 to the 7th. It's about 1 to 50 million. Divide yourself down by 50 million, and that'll give you your height on a basketball. Your height is divided by 5.08 times 10 to the 7th equals 3.9 times 10 to the minus 8 meters, and that comes out to 39 nanometers. That is one tiny little object. You're going to be sitting on this basketball and you're going to be surprised at how small you really are. And that's going to tell you how small you really are relative to the earth. All right, at this scale, if you were shrunk down to 39 nanometers, you could see that in our world, at the earth level, the DNA inside the nucleus of a human cell is only 2 nanometers across. Well, in your small world, on the basketball, a coffee cup, mine's about 4 inches tall, so that's about 0.1 meter. That coffee cup is going to be about 2 nanometers in size, 1.9 nanometers. In other words, DNA double helix balled up in a cell would be about the same size as a coffee cup. And so you could look at it, inspect it up close with your very own eyes, because you'd be that small. And if you think about the earth, if you look at your body, you can't see the separate cells. You can't even come close. So it gives you an idea of how tiny you really are on this basketball world. Here's another item that you might find interesting. At the size of 39 nanometers, you're going to be small even relative to something like a virus. And remember, bacteria is way bigger than a virus even. So this is a really tiny object that's about as small as you can get and still be alive, if viruses are alive. There's some debate on that. But the virus is going to be somewhere between 50 and 200 nanometers in diameter. Kind of looks like a World War II mine that they'd mine a harbor with. It's got little spikes on it and everything, but that's the size of it. And compared to you at your 39 nanometers, it's going to be bigger than you are. You'd probably want to run and hide if it came after you, kind of thing. It's very large compared to you. So again, this shows you how teeny tiny you would actually be on this basketball world. And it actually shows you how teeny tiny you are on our world. And that's critical for you to understand what you're looking at when you look around at the horizon. Okay, well, let's look at things that are visible to the naked eye. The smallest item that any normal human eye can see without any magnification is 20 micrometers. I mean, this is 500 times your size of 39 nanometers. So you obviously, sitting on your ball, somebody was looking down at you, they could not see you at all. Just like you can't see a virus. I mean, you're just way too small. So how about a optical microscope? Surely you can be seen there, right? No, even there you would not be discernible, because an optical microscope requires optical light, and the shortest wavelength for visible light is in the violet range, and violet runs from 380 to 450 nanometers. The absolute best resolution you can get out of an optical microscope, the best it can do is half of the wavelength of the shortest wavelength there. And in this case, that's going to be 190 nanometers. You divide 380 by 2. And that's still 5 times bigger than you are. So even with a microscope, you couldn't be seen on this basketball world. You could be seen with an electron microscope, because it'll go down to 50 picometers. However, they use an electron beam that would kill you. You'd die. So there's no way you could wave to the folks back home, even with an electron microscope. So you are just so small, you're just undetectable by any, and still be left alive by any of the visual means that we have. I worked for a number of years in clean rooms. I also taught the equipment that I serviced in the clean room too, the ion implanter. But they're very concerned with particles. They want cleanliness in a clean room. And in the area I was working, we had silicon chips, and they were creating very tiny microscopic devices on the wafer. The wafer might be 8 inches across and have hundreds of devices on there. Each one is very, very tiny. So a particle getting in the way of the ion beam coming in, hitting it to do an implant to create the various transistors and other elements on there, a particle in the way could destroy a device. So the people in charge of the clean room, of course, wanted to keep all those particles out they possibly could. So they would classify clean rooms based upon how many particles are there. And you'd want a very, very small number. They didn't even worry about any particles that were smaller than 100 nanometers. That would be a tiny particle that they wouldn't even bother with. And you, in this small state on this basketball world of yours, would be less than half that. So you're too small to count even as a particle in a clean room. Okay, we have a human hair. How big would that be to you in this small world you're living in, this 39 nanometer height you have? Human hair can be up to 180 micrometers in thickness. If we convert that value by multiplying the ratio of the radius of the Earth and radius of the ball, you end up with 9,505 meters. How tall is that? Well, Mount Everest is 8,848 meters. So that hair would appear taller to you than Mount Everest, what does to you now. And a plane flying at that altitude would be flying at 31,000 feet. So that's a very, very short object on the basketball, yet to you it's huge. So you can see why, standing on top of that hair even, you wouldn't be able to see a curvature of the basketball. Everything would still look flat because you are so teeny tiny on that basketball world. Okay, how big would you be relative to a raindrop hitting the basketball? Raindrops can range anywhere from 0.5 millimeter to 4 millimeters. Or smaller than 0.5 millimeter, they won't drop. They'll just hang in the air. They hit 0.5 millimeter, they'll start to fall. If they get up to 4 millimeters, then they will usually cleave into 2, and so you end up with 2 millimeter raindrops. So they're going to be somewhere between 0.5 and 4 millimeters. So how big would the smallest raindrop be to you on this basketball world? And when it comes down and hits you. Of course, you can't be seen, you're too small. At 0.5 millimeter, if you multiply that times a ratio between the radius of the Earth and radius of the ball, will come out to 26,404 meters. That's 26 kilometers or 16 miles. Yes, you would be dead if something like that fell on you on that basketball. It's a huge amount of water coming down. 16 miles across, that's amazing. Well, how about the big raindrop? How big would that be? That's even more scary. If you go 0.004 meters times that ratio, you end up with 211,235 meters, which is 211 kilometers or 130 miles. That is a huge amount of water coming down. We're talking Great Lakes combined hitting you. Of course, you would not survive that. Look at it's the state of Connecticut is 110 miles by 70 miles on its width and height. So this raindrop is bigger than the state of Connecticut, significantly bigger. So that's how big a raindrop would appear to you, a raindrop from our world hitting you in your basketball world. So in conclusion, why don't you see the curvature of the earth? Well, it's because you're just too small. You're way too small. You imagine a little virus sitting on the top of a basketball. There's no way it's going to see the curvature of the basketball. It's too tiny. Even flying in a plane, your elevation's not going to be high enough. You're not going to get up there enough to see the curvature. That's only as tall as a human hair would be to you on the basketball. It just isn't going to happen. So don't let people lie to you and say, well, it can't see the curvature of the earth, therefore it isn't round. That's silly. It's just because you are so small relative to the size of the planet Earth. I hope you found this video helpful, and if you liked it, click like, and if you haven't done so, please subscribe, and I'll see you next time.